Have you started that?
I like decomposing the average piece by piece, not in general, not all the time, but right now, because I want you to see each piece of the average. This is going to result in one monetary value, yes? It's going to result in one monetary value. But when you decompose it like this, you see the individual component pieces of the average and which piece contributes the most to the average. So let's do it piece by piece, okay? Rather than just telling me what this equals, let's do it. What is -1 times this? Well, that's negative 0.5773. So that's a loss of 58 cents. This would be the amount you would lose every game if they just didn't ever give you profitable amounts of money. In other words, if they simply took your ante if you lost and gave you $1 back if you won. That's what your average would be. That's negative. So what do? Well, they give you $0 back. Well, they give you $1 back, which makes you profit $0. 35% of the time. That doesn't help you in your overall profit winnings, but it helps you mentally want to keep playing the game. Now there are also non-numerical things they do to keep you playing the game, like giving you free drinks. There's all kinds of things they do to keep you playing the game besides psychometric, well, besides mathematical metric ones. Right. Right. Now watch this. Here's the first profit-bearing one, right? $1. But when you apply that to the actual probability of it happening, it only represents 6.77 cents on average. That hardly knocks down this, makes it positive, does it? Then you're like, oh, don't worry about it. I'll make it up with the big 5 rolls. Sure, if you think about it that way, the problem is, what is 9 times that? Is that like 0.02? What does that mean? Say it again.
0.0333.
333?
And the other one you have to times by 2 because it's...
Which one?
The 0.0677 because it has to average out the one other dollar. I mean, so you're getting...
Oh, I've taken that dollar out. All of these assume you've already... So what Scotty is saying is, you got to make sure you account for the ante somewhere. Now that's called an insurance premium payment. We're about to get into that in class quiz. But that's funny. I pointed at the phone gloves. That was kind of weird. But the idea, we've already accounted for it, Scotty. If I didn't account for it, I would have 0, 1, 2, and 10, and then put a -1 at the end of it. You have to account for the ante somewhere. I just did it in the profits.
Oh, no,
Is that fair? So when you look at these 4 pieces taken together, you realize that's the average win. That's the average result you lose from the relative frequency of the time you never roll 5s. This is the non-contribution of the time you roll 1 5. It doesn't contribute anything mathematically, but it contributes something psychologically to keep you playing. And then the billboard on 97 and that irrational voice in your head that says, I'm going to make it up eventually. But what you're going to make up, you have no way of measuring eventually, because that's all you're making up. So you what? You got 10 cents here, which is offsetting 57 over here. So what do you end up losing, friends?
-47.
Uh-huh. You guys getting this 47 cents? Is that what we're getting? So, what this essentially means is, rather than going through all the hoo-ha of playing the game, rather than walking up and giving him $1 and then dealing with the sometimes, just walk up with 47 cents, put it on the table and walk away. Because that's what's happening on average, isn't it? On average, you're losing 47 cents a game. Does that make sense? That's an average. It doesn't talk about the individual inconsistencies of what happens in the game. Right? It doesn't talk about the... But that's what's going to happen to you if you keep playing the game. That's why it drives me insane when I hear these people go, just keep playing! You're almost there! Where? To infinity? What do you mean almost there? What you do is if you hit a streak where you win a bunch, you walk out. You interrupt it in the random fluctuation, right? You've seen Casino, the movie Casino? The scene with the Japanese businessmen is proof positive. I love the fact they snuck that scene in. Do you remember that scene? Bunch of Japanese businessmen playing, I forget what game they're playing. It's one of these games, craps, let's say it's craps. And they hit one of those random fluke where they're actually winning a bunch. And they try to leave. Why? Because they understand statistics. And De Niro, he cancels their flight. He essentially calls the airport and says, cancel the flight, make it look like the plane can't take off. And they come back to the hotel all pissed off. They can't get on our plane. He's like, oh, I'm so sorry. Here, best room in the house. Here's some chips. Go keep playing. What happens? That will always win. That will always win. Always. It has to. Assuming that the numbers are falling with those relative frequencies. That is a guarantee over time. Isn't that wild? Now, you have to know this going into Vegas, right? You have to know this going into Vegas. Just keep this always with you and you'll understand why you're going to walk out with pockets that are lighter when you walk in. If you know this, it's no different than going to the movies. You happily give 20 bucks at the movies for a ticket and like $82 for popcorn. You happily foist that over to spend 2 hours in a darkened room watching special effects, right? Happily. I watched Life of Pi 5 times. I mean, how many hundreds of dollars did I spend watching Life of Pi? Because it was so good. Happily, because it's entertainment. Just like gambling is. Now we're going to talk about why it's not entertainment using this quiz in a second here. But I want to make sure, even though we did this one by hand, I don't want you always doing these by hand. Make sure you can get these numbers in your TI as well, yes? Let's do that as well.
Wasn't this also kind of a ratio of the housing market here in 2000?
Oh, the problem, Scott's got a good point. Scott's got a very good point. The trick with these probabilities is you have to be able to establish them to know how to analyze them, right? That's why I said, Tara, give me a couple minutes on your comment about they're not going to play. They are going to play if you win 1/3 of the time. If you're always getting a dollar back 1/3 of the time. If those probabilities are changing, it becomes a very, very different argument. But the thing about it is, how often in those Vegas casinos are they going in and checking the balance of the machines? Always. Because they are banking on that negative 47 cents every time somebody plays. When they see somebody walking up to a craps table, they don't think, my God, they might win big. They think, there goes 50 more cents in our pocket. Because that's how they think. Even with that billboard. Why the hell would they advertise that? Somebody just won $948,000. Do you think it's going to happen again? Why would they put that up there? To get more suckers to come and give them money. Right? That's the point. To get, as soon as you walk up to the table and you pull the thing, you've given them $1 or 50 cents or 20 cents depending on the game. The outlier is just that. Something that doesn't happen very often. Oh, good stuff. Let's do it. Make sure you can do it. Then we'll get to our quiz. All right. So stat edit. Let's see what we got here. I'll go L3, L4.
Caffeine-induced thinking.
Caffeine-induced thinking. There's an old statement that, what is it? Coffee is a tool for turning mathematicians into ideas. I like that one. Jessica had never heard that one before, which I thought was funny. So all I'm doing, friends, is I'm using L1, L2. It's just the weighted average, isn't it? It's just the weighted average. FYI, the probabilities that you're getting here in L2 can be calculated manually, and I'll have you do it in a couple weeks. It's a very specific kind of a distribution that I want to start getting into on Monday with you guys called the binomial. We'll talk about my chicken flock again, because they're actually a perfect example of a binomial distribution. Cool? We'll see how. Cool so far? Run it. Make sure you do L1, L2. If you don't do L1, L2, you're going to get an answer. And you're going to want to go in that casino and expect to make money. Because you've ignored it, right? Make sure you're on L1, L2. There we go. Just about a loss of 48 cents per roll. Hey, check this out. Notice anything interesting? You see this right here? Remember what S is?
Standard deviation.
Of the what? Oh, good, good. More micro, less macro. Very good macro answer. Thank you, guys. Of the average. Of which average?
The average.
Why is it called S?
Average of the average, right?
Why am I making the S with my neck?
The winning.
Average distance.
Somebody just said it. Thank you, Linda. It's a sample standard deviation, right? It's the sample standard deviation. That's why it's called S. Notice it's gone, right? But notice this one's still there. This is little sigma, yes? Remember, I've only mentioned them a couple times, but little sigma is the standard deviation of who? Say it, be brave, Andrea. The whole population. How dare we? But if you think about it, don't we have the population of results? That is what's going to happen when you throw 3 dice. Believe it? That's what's going to happen. If you throw 3 dice, Those four things are the population of results. Those are the frequencies it happens at. It's no longer a sample. You actually have the entire set of results now. Badass if you think about it. That's pretty badass. Which means there is no uncertainty in that average. There's no reason to put a plus or minus on it. As a matter of fact, what the hell? You can even call that mu if you want to. Remember mu, the population symbol? Mu, the kid. It's a population average. There is no deviation from that. You will lose 48 cents per game. On average.
So is the 80.84 representation of like the
It's,
entire population?
now here's the deal, friends. I want you to ignore that for the most part.
Okay.
That is 84 cents of standard deviation. The problem is, you can't really use it. The data is so skewed, it's so ridiculously skewed, that the standard deviation is really, it's meaningless, really. That is not, though. That tells you what's going to happen to you on average over time. Instead of playing the game, just walk up and give them 48 cents. Call it good. I mean, really, if you think about it, that's all it is.
But people play for what? Entertainment.
For fun.
And you should. The same reason I go to the movies and I watch Life of Pi on a screen versus wait until it comes out on DVD. Which, of course, I bought it anyway, of course. But because it is entertainment. But the expectation that you're going to win money and walk out with more than you have is a false one. That's all I'm pointing at, right? You should play for entertainment, only entertainment, yes? Because it should be entertainment, it's fun. It's kind of like this parallel velour carpeted reality, right? You should play for entertainment. It's just like going to the movies in that respect. But just realize when you walk out, you've paid for that privilege of having that entertainment. Good? Very good point. Randall?
I'm getting a slightly different thing than
Me
you are.
too.
Different thing?
Got a lot of
It's off by a teeny bit. Hang on a second. Did we put the exact same values in? 5773, 3513,
6-7.
Oh, I put 667, not 677. I'm sorry.
That's what I know.
That's why I'm off a little tiny bit. I'm sorry. But as Randall pointed out, it's a very, very minor difference.
Very minor.
Yeah, it still rounds to 48 cents. Thank you. I transposed a 6 and a 7. Fair? Every casino game of chance has a T-table. Not that T-table, but has a T-table, whether it's roulette, whether it's craps. You guys actually did it in 105. You did the craps T-table in 105.
It was horrible.
Whether it's roulette, craps, chuckle up. Now the games of skill are totally different. The games of skill, and this is why I mentioned before, the housing market's hard to measure because the probabilities vary. Just like somebody that plays poker. I suck at poker. What are you going to do, Sean? I don't know. Give me a card. I mean, that's how I decided to play poker. I can't count cards. I barely know what beats what in poker. But games of chance are ruled by that table. And that's why the last thing I want to do today is I want to analyze the game of chance applied to your life. So what I did here, you might want to break up with each... That sounded a little bit harsher than I wanted it to. I'm sorry. Applied to your life. Actually, it's applied to my life.